In the depths of Earth's ancient past, the skies were ruled not by birds or bats, but by colossal insects. Imagine creatures so large they dwarfed anything we see today, like meganura, a dragonfly with a wingspan over 2 feet wide. Welcome to the Carboniferous period, a time when giant insects dominated the skies. Imagine a world where colossal trees reached for the skies, their leaves forming a dense green canopy that filtered sunlight into a soft, dappled glow. This was the Carboniferous period, a time long before the age of dinosaurs when the Earth brimmed with lush forests and humid swamps. Here, ancient trees known as lycopsids and ferns grew to extraordinary heights, creating a paradise for an array of life forms, both plant and animal. The landscapes were an explosion of green, with towering trunks that could rival modern skyscrapers, providing shelter and sustenance to countless creatures. Among the most astonishing inhabitants of this era were the gigantic insects that soared through the air or crawled along the forest floor. Meganura, a dragonfly-like creature, stretched its wings to an impressive span, making it one of the largest flying insects known to man. As it darted through the humid air, it preyed on smaller insects, a true aerial predator of its time. Meanwhile, pulmonoscorpius, a fierce scorpion, wandered the underbrush with its lengthy pincers at the ready, an intimidating presence in the shadowy world of the Carboniferous forest. On the ground, the massive arthropleura, a giant millipede, scuttled through the damp soil. Growing over 2 meters long, its segmented body and numerous legs allowed it to navigate its environment with surprising agility. These enormous arthropods thrived in the warm, moist climates of the Carboniferous, feeding on decomposing plant material. As they moved through the dense undergrowth, they played a crucial role in breaking down organic matter, thus contributing to the nutrient cycle of their rich ecosystem. This age of giants was not solely defined by its flora and fauna, but also by the formation of vast coal deposits. The lush plant life, upon dying and accumulating in the swampy lowlands, eventually transformed into the coal seams that are vital sources of energy today. As the climate shifted and the forests retreated, new ecosystems emerged, forever altering the course of evolution. The legacy of the Carboniferous period still echoes today, influencing both our natural world and the resources we depend upon. The Carboniferous period serves as a reminder of the Earth's ever-changing nature and the extraordinary life forms that once roamed its surface. Delve into this prehistoric time and visualize a world where both plants and insects grew to remarkable sizes, painting an unforgettable picture of nature's grandeur. In the distant past, our Earth was home to colossal insects that ruled both the skies and the land, capturing the imagination of scientists and enthusiasts alike. These apex predators, some as large as modern birds, thrived in lush environments teeming with life. But what factors contributed to their immense size? One significant element was the abundant atmospheric oxygen levels during the Paleozoic era. Investigations suggest that oxygen concentrations were up to 35%, significantly higher than today's 21%. This surplus allowed insects to grow larger due to more efficient respiration. Their exoskeletons, however, posed limitations. The larger they grew, the harder it became to regulate water and energy effectively, thereby creating a unique dynamic between size and survival. Additionally, the absence of large vertebrate predators during those times contributed to the unchecked growth of these insects. In the blink of an eye, when monstrous insects like meganura, with a wingspan of nearly 2 feet, dominated the skies, they faced little competition. The natural selection worked in their favor, allowing for extreme adaptations that aided their survival and ascent to apex predator status. Climate played a crucial role too. Warmer temperatures meant more extensive habitats could support a diverse range of species. These thriving ecosystems with copious food sources provided ideal breeding grounds, enabling insects to grow and evolve into larger forms. For instance, the giant dragonfly-like creatures preyed upon smaller insects that were abundant, demonstrating a thriving food chain where size conferred distinct advantages. Lastly, we must understand the iterative nature of evolution. Over millions of years, these insects adapted to take advantage of available resources and ecological niches. Larger body sizes offered benefits like competitive advantages in capturing prey and resisting environmental challenges. However, as the planet evolved, ecosystem shifts eventually favored smaller insect sizes, leading to a decline in these grand creatures. The story of these enormous insects serves as a poignant reminder of Earth's historical biological diversity and adaptability. As we unravel the mysteries of their existence, questions about size, environment, and ecological interactions persist. The legacy they left behind inspires awe and curiosity, leaving us to ponder what other colossal wonders may have roamed our planet long before our time. Imagine wandering through dense, lush forests where enormous insects flit about, their wings buzzing like miniature helicopters. During the Carboniferous period, roughly 359 to 299 million years ago, a remarkable phenomenon unfolded. Massive insects roamed the Earth, thriving under conditions that today might seem fantastical. The secret behind their colossal size rests in the atmospheric composition of that ancient time. Oxygen levels were dramatically higher then, around 35%, compared to the current 21% we breathe. This extraordinary abundance of oxygen fostered a unique environment where life could thrive and evolve in ways that challenge our modern understanding. Insects, which breathe through a network of tubes called tracheae, could efficiently absorb more oxygen, fueling their growth to sizes previously thought impossible. Picture giant dragonflies with wingspans reaching nearly 2 feet, hovering effortlessly among towering ferns and cycads. These were not mere fantasies. They were real creatures, a testament to the rich, oxygen-laden air that enveloped their world. The dense flora of the Carboniferous period, with its skyscraping trees and expansive swamps, created the perfect backdrop for these gigantic insects to flourish. It was a time when massive arachnids and enormous millipedes roamed, casting shadows on the forest floor. However, the changes in Earth's atmosphere didn't just influence the insect kingdom. They shaped entire ecosystems. The lush vegetation produced vast amounts of oxygen through photosynthesis, which in turn supported a wider range of species, including the early ancestors of modern reptiles. This period marked an ecological golden age, where life experimented with size and form in extraordinary ways. Fast forward to today, and the very notion of such massive insects seems like the stuff of science fiction. As oxygen levels dropped over millions of years, the sizes of these creatures diminished, adapting to the new conditions of our planet. This ancient era serves as a poignant reminder of how environmental factors significantly influence evolutionary paths, pushing the boundaries of size and survival. Understanding the role of past atmospheric conditions can illuminate not only our planet's history but also inspire deeper questions about the resilience of life. What if similar oxygen-rich environments were artificially recreated? Could we witness the return of giants? While it remains a tantalizing thought, the Carboniferous period remains etched in the annals of history as a time when the sky teemed with colossal creatures, born of an Earth transformed. Insects, the most diverse group of animals on Earth, breathe through a unique system of tiny tubes known as tracheae. These intricate structures extend throughout their bodies, branching into smaller tubes that deliver oxygen directly to their tissues. Unlike mammals, which rely on lungs, insects have adapted this efficient method of respiration to thrive in various environments, optimizing their energy use for growth and activity. As the ancient atmosphere experienced fluctuations in oxygen levels, the potential for insects to grow larger became a reality. With a higher concentration of oxygen in the air, their bodies took advantage of this abundance. Oxygen-rich environments nurtured gigantic species such as meganura, an enormous dragonfly-like creature that soared through the prehistoric skies. This evolutionary advancement allowed insects to dominate aerial territories, with exceptional agility and size, outcompeting other species. The anatomy of the tracheal system plays a pivotal role in this growth. Tracheae open to the outside through small spiracles, allowing a direct connection to the air. This system not only provides the necessary oxygen, but also facilitates the elimination of carbon dioxide. As insects became larger, these spiracles had to adapt to regulate airflow more efficiently, ensuring that oxygen could reach every cell in their sizable bodies. The exceptional capacity of tracheae enabled these ancient giants to sustain high levels of physical activity, a feat that would be challenging for larger animals relying on lungs. Exploring the relationship between oxygen levels and insect evolution unveils a fascinating glimpse into the past. In times when Earth's atmosphere had a significantly higher percentage of oxygen, it was not just the size of insects that flourished, but also their ecological roles. Enormous insects could travel greater distances, expand their territories, and seize new opportunities for survival. This increased mobility allowed for broader interactions with plants and other organisms, further shaping their ecosystems. The triumph of the tracheal system stands testament to the resilience of insects amidst climatic shifts. As oxygen levels fluctuated throughout history, these remarkable creatures adapted, thrived, and left their mark on the world. The legacy of giants like meganura reminds us that the smallest systems can yield some of the most extraordinary evolutionary outcomes. By understanding the intricate breathing mechanisms of insects, we gain insights into how life adapted over millennia, reflecting nature's marvelous ingenuity. In the primeval skies of the ancient world, a creature soared with grace and fearsome agility. Meganura, often dubbed the giant dragonfly, ruled the airwaves with a wingspan that exceeded 2 feet. With its swift movements and sharp predatory instincts, it was one of the most impressive insects of its time, capturing the imagination of those who study ancient ecosystems. Characterized by its strong, translucent wings that gleamed in sunlight, meganura elegantly glided over primordial landscapes, its shadow cast on lush ferns and sprawling conifer trees. This colossal insect was not merely a passive aerial being. It epitomized the thrill of the hunt, swiftly darting through the air to capture unsuspecting prey. With keen eyesight capable of spotting movements from great distances, nothing escaped its attention, making survival an arduous game for smaller insects and even small vertebrates. The anatomy of meganura was as fascinating as its hunting prowess. Its elongated body, adorned with intricate patterns, was built for speed and agility. As it zipped through the vibrant ecosystem, the gentle hum of its wings created a soundscape of life, seamlessly intertwining with the rustling leaves. This symphony of nature emphasized the duality of beauty and fear, as meganura collected sustenance by snatching precious life from the air. Within the lush greenery and under the canopy of ancient trees, meganura found its territory, a vast expanse filled with an abundance of prey. Its skillful hunting methods were marked by quick, calculated movements, striking with precision. The constant quest for survival painted an ever-competitive backdrop, showcasing not only the magnificence of this creature, but also the delicate balance of the ancient ecosystem. The shadows cast by meganura served as a reminder of nature's raw power. However, as time progressed and the climate changed, meganura gradually faded from the skies. This magnificent relic of the past reminds us of the evolutionary wonders once present on our planet. Today, scientists study meganura to understand the climatic shifts that led to its extinction, revealing clues about environmental changes and adaptations through the ages. While it may no longer inhabit the Earth, the legacy of meganura continues to resonate in the annals of paleontology, echoing the glory of ancient skies where giants once soared. On the ground, pulmonoscorpius, a giant scorpion measuring over 2 feet long, stalked its prey with an eerie precision. Its movements were both fluid and deliberate, a testament to its ancient lineage, as it roamed the primal landscapes of a long-lost world. Imagine the atmosphere, dense with humidity and teeming with other creatures, where the air itself seemed to vibrate with anticipation. This formidable arachnid was at the top of its food chain, a hunter in a forgotten age with instincts honed by millions of years of evolution. As it crept along the damp earth, its powerful pincers gleamed like polished obsidian, more than mere weapons. They were tools of survival. Each pincer opened and closed in a subtle dance, ready to capture anything that dared to cross its path. The crunch of foliage beneath its weight was a whisper of doom to its unsuspecting prey. In the jungle of ancient ferns and towering cycads, the thunderous sound of approaching danger reverberated, sending smaller creatures into a panic. Every step taken by the pulmonoscorpius was a silent ode to its role as a relentless predator. Then there was its venomous stinger, a lethal spear poised to deliver an unrelenting blow. Picture the sheer terror of facing such a creature, its tail elegantly arched above its back, ready to strike in a heartbeat. As it approached, the stinger glowed ominously, a harbinger of its deadly capabilities. The combination of size, strength, and venom transformed this ancient scorpion into an unstoppable force, ensuring its dominance over the rugged terrain it called home. The fear it invoked was as palpable as the humidity balled around it, thickening the air with an instinctive dread. In this primordial setting, the pulmonoscorpius not only survived, it thrived. It served as a reminder of nature's power and the delicate balance of life and death. When you contemplate these colossal beings, you don't just see a creature of nightmares. You see an essential part of the ecosystem. The giant scorpion was both a predator and an integral player in maintaining ecological equilibrium, ensuring that life in this ancient world unfolded in an intricate tapestry of survival, adaptation, and resilience. Truly, the pulmonoscorpius captures the wild essence of Earth when it was young and feral, a beast whose legacy still lurks in the shadows of our fears. Imagine a world where colossal creatures roamed the Earth, long before the age of mammals. Among these fascinating beings was arthropleura, a millipede-like invertebrate that stretched up to an astonishing 10 feet. Picture this giant wanderer gliding gracefully over a dense carpet of primordial ferns, its segmented body glistening in the dappled sunlight, filtering through the ancient canopy. Arthropleura thrived in the lush, steamy environment of the Carboniferous period, when the air was rich with oxygen and plant life flourished. Picture vast forests filled with towering trees and dense undergrowth, offering a verdant paradise for this hefty creature. As it wandered through its realm, its imposing size not only commanded attention but also shielded it from potential predators lurking in the shadows. Despite its formidable presence, arthropleura was not a fearsome predator. In fact, evidence suggests it was herbivorous, feeding mainly on decaying plant matter that blanketed the forest floor. Envision the creature delicately navigating through heaps of fallen leaves and rotting vegetation, using its many legs to carefully sift through the earth in search of nutrient-rich morsels. Its diet played a crucial role in the ecosystem, aiding in the breakdown of organic matter and enriching the soil. The anatomy of arthropleura is a marvel of evolution. Its elongated body, composed of numerous segments, bore many legs that propelled it through its habitat. Each segment moved rhythmically, creating a wave-like motion as it traversed the forest floor. Consider the vibrant colors that may have adorned its exoskeleton, blending harmoniously with the surrounding greens and browns of the prehistoric world. It was a creature perfectly adapted to its environment, embodying both magnificence and practicality. As millions of years passed, the Earth underwent dramatic changes, leading to the eventual extinction of arthropleura. Yet it remains an extraordinary testament to evolutionary creativity, sparking wonder about the biodiversity of ancient life. The legacy of this gentle giant endures through fossil records, captivating the imagination of paleontologists and enthusiasts alike. Each discovery offers a glimpse into a time long lost, where nature's wonders defied the boundaries of size and scale. In the lush green realms of the Carboniferous period, a captivating world thrived, filled with colossal insects that dwarfed the creatures of today. Towering dragonflies with wingspans as wide as a human arm flitted among ferns, while giant millipedes sprawled across the forest floor, their segmented bodies sparkling in the dappled sunlight. The climate was a tropical paradise, with humidity and warmth nurturing a cascade of life, allowing these extraordinary insects to flourish in unprecedented sizes. However, as time pressed on, the Carboniferous period began to fade into history, ushering in significant changes upon the Earth. The atmosphere, once rich in oxygen, began to shift, becoming less conducive to sustaining life in the form and scale that had become so legendary. This transformation was gradual yet profound, casting a shadow over the robust ecosystems that had relied on high oxygen levels as an essential element for growth and survival. As oxygen levels dropped, the gargantuan bugs faced new and daunting challenges. Their immense bodies, once perfectly adapted to the swathes of oxygen in the atmosphere, began to find themselves at a disadvantage. These insects, which had evolved over millions of years to reach their colossal sizes, now struggled to obtain sufficient oxygen to sustain their bodily functions. The struggle was not just about size, but about survival. Their very existence hung in the balance amid a changing world. The once thriving giant insects gradually began to dwindle, their reign cut short by the firm hand of an environment that no longer embraced them. Fewer offspring survived, and the genetic lines of the titans of the past began to fade. Smaller species, those more adaptable to the diminishing oxygen levels, started to rise and take their place, marking the end of an era and contrasting sharply with the giants that once ruled the skies and forest floors. This shift marked a pivotal moment in the history of Earth's biosphere. It led to the evolution of smaller, more efficient insects that could thrive in the changing atmospheric conditions. Despite the decline of their gigantic ancestors, the legacy of these fascinating creatures continued to resonate through evolution, serving as a reminder of how life adapts, evolves, and finds a way to thrive, no matter the challenges it faces. The age of the giant insects may have ended, but their story remains one of nature's most striking tales of glory and transformation. In a time long past, the Earth was a primordial realm where colossal insects roamed broadly. Towering above modern creatures, they flourished in an atmosphere rich with oxygen, thriving in diverse environments teeming with life. These giants, with their intricate exoskeletons and vivid colors, painted a vivid picture of an ancient world, capturing the imagination of all who study their fossilized remnants. However, as the climate began to shift, so too did the conditions that fostered their existence. Gradually, a reduction in atmospheric oxygen levels and changing landscapes brought the reign of these leviathans to an abrupt end. The once verdant forests became less hospitable, and competition grew increasingly fierce. Smaller, more adaptable species began to emerge, forging a new chapter in the evolution of life on Earth. As towering insects faded into the annals of history, a transition took place in the ecological balance, establishing a foundation for future ecosystems. Despite their extinction, the legacy of these magnificent creatures lingers on, captivating our curiosity and encouraging us to delve deeper into the mysteries of our planet's history. Scientists continue to study fossilized remains, piecing together a comprehensive narrative of their biology, behavior, and the habitats they inhabited. Museums proudly showcase these extraordinary fossils, allowing us to glimpse the grandiosity of a time when the world buzzed with the sounds of dragonflies, the size of hawks, and beetles resembling small cars. The wonder of their existence serves as a reminder of nature's boundless creativity, adapting to its surroundings while reflecting the delicate balance of survival. Moreover, the fascination with giant insects transcends mere scientific inquiry. It inspires artistic expressions in literature, film, and visual art. Their legacy resonates in stories of horror and wonder, reminding us of the complexities of evolution and adaptation. The image of a colossal creature soaring through the air captures the imagination, presenting a vibrant tapestry of what once was. Through these cultural reflections, we are beckoned to contemplate not only the past, but also the trajectory of life as it continues to unfold in today's changing world. Ultimately, while the era of the giant insects may have drawn to a close, their story continues to inspire generations. They teach us invaluable lessons about change, resilience, and the intricate web of life that binds all creatures together. As we ponder their legacy, we become recipients of their history, charting a course into an uncertain future while honoring the wonders of the past. In the tapestry of Earth's history, ancient giants once roamed the skies, dominating the ecosystems of their time. These magnificent creatures are ancestors of the modern insects we see today, yet their legacy is often overlooked amid the hustle of contemporary life. Picture the dragonflies of today, their iridescent wings sparkling in the sunlight, echoing the grandeur of their forebears with their graceful aerial maneuvers and specialized predatory skills. The distant echoes of massive scorpions can be felt in the resilient arachnids that traverse our landscapes. Once as large as a human hand, these ancient predators ruled the oceans and later evolved to adapt to terrestrial environments. Now, as we observe their smaller relatives, we can appreciate how these ancient giants shaped the evolutionary path of countless species. The scorpion's fierce demeanor and adaptable nature have enabled them to flourish through epochs, embodying the spirit of survival in even the harshest conditions. Millipedes, too, carry the weight of history in their segmented bodies and slow, deliberate movements. Once giants of the carboniferous period, they remind us of Earth's lush prehistoric ecosystems. The soil they enrich with their decomposition processes continues their legacy, turning ancient nutrients into sustenance for future generations. Visualizing these creatures in their prime, swarming in vast numbers beneath the dense canopy, brings to life the complexity of past ecological networks. Yet, the stories of these ancient giants extend beyond mere physical forms. They represent a remarkable chronicle of adaptation and resilience. The struggles for survival in diverse climates and environments paved the way for the rich diversity of insects we observe today. The remnants of their existence lie not just in the fossil record, but also in the genetic blueprints embedded within their modern descendants. Though centuries have passed since these creatures ruled the earth, their influence lingers. The essence of their extraordinary adaptations and evolutionary triumphs is visible in today's insect worlds. As dragonflies dart across ponds, scorpions hide beneath rocks, and millipedes work industriously among fallen leaves, they carry forward the timeless stories of their ancient predecessors. Every flutter, scuttle, and crawl hints at a legacy that not only survived, but thrived, illustrating nature's unyielding ability to transform. In a world ever-changing, the ancient giants remind us that the past is not lost. It continues to shape the present and inspire the future. As we observe the creatures around us, let us remember those colossal ancestors, whose echoes still resonate through the living tapestry of our planet. Their legacy lives on in every wingbeat and every scuttle, a reminder of the intricate connections that weave together the story of life on Earth. Insects, the unsung heroes of our planet, have roamed the earth for millions of years. Their story begins in the Carboniferous period, a time when lush, sprawling swamps dominated the landscape. Giant dragonflies, with wingspans resembling that of modern birds, soared above murky waters, predating other creatures with their aerial prowess. These magnificent beings thrived in a world filled with towering ferns and abundant moisture, showcasing nature's creativity and adaptability. As we journey through time, we witness the transformation of these ancient insects. With each new era, they evolved, responding deftly to changing climates and landscapes. The Triassic saw the emergence of the first butterflies, graceful and colorful, with delicate wings that caught the sunlight like stained glass. Their magical dance among wildflowers created an intricate tapestry of life, as they played essential roles in pollination and ecosystem balance. In contrast to their delicate peers, some insects adapted to become formidable predators. The Jurassic period bore witness to the rise of wasps, transforming the skies into a battleground. Armed with venom and agility, they became nature's enforcers, maintaining the delicate equilibrium between plant and prey. The interplay of life and death unfolded with breathtaking intensity as these resilient creatures thrived through adaptation and sheer will. Fast forward to the present, and insects remain crucial players in Earth's games of survival. They've navigated the transition from prehistoric swamps to modern urban jungles with astonishing flexibility. Ant colonies build intricate networks beneath our feet, while bees tirelessly pollinate the crops that sustain humanity. This connection to our agricultural world ensures that their ancient lineage continues to impact our lives profoundly. Yet, as we reflect on their legacy, we must also recognize the fragility of their existence. Environmental changes, habitat destruction, and climate change threaten these tiny warriors of the natural realm. The silent struggle unfolds as we grapple with our responsibility towards preserving their habitats. Advocating for biodiversity is not merely an act of kindness, it is a necessity for the survival of both insects and humanity. Our understanding of these ancient insects teaches us resilience. Their ability to adapt serves as a powerful reminder of the interconnectedness of all living beings. We must cherish and protect the remnants of their world, understanding that in doing so, we safeguard our future. The lessons of the past echo loudly through time, urging us to appreciate the delicate balance that sustains life on Earth.